Good morning, Pre Algebra. I'm not sure. This is lesson 6.7. So get out your notes and follow along. All right. We will review on Monday when I get back. Tuesday we'll review again, and then Wednesday will be the test. Okay. So don't get all upset and worried. I'm going to test you without helping you. I will help you, but this will help you be able to do the homework, and you can work on that after we're done going over this. All right. So what we're going to be doing is we're going to take the next step in using algebra. So we've done combining like terms. So when we combine like terms, how did we do that? Like, what did we do to combine like terms if they had the same variable? So what's a variable? Variable. Devin, can you answer that? What is the variable? A variable. A letter. Good. Devin, that was perfect. So a letter. So when it represents a letter, that's a variable. Okay. So when you have different variables like x's and y's, then you might not be able to solve those, but you can at least put them together. Okay. Now in this lesson, what we're going to learn is how to write the equation so you can solve for the variable. Okay. So whatever that variable is. Now, some of you are going to use x, and some of you are going to use y, and some of you are going to use your favorite letter. We don't know what that favorite letter is, but whatever that favorite letter is, you'll use in this case, okay? They will use in math a lot of times is x, okay? So x and n are like the two most common, x, y, and n are those main common ones they use. So what we're going to do in this lesson is we're going to first off write an equation, okay? Learn how to write the equation and then solve equations, okay? So what you have to do first is you have to make sure that you understand what you're looking for. So every problem has something you're looking for. So I'm going to read a problem. I want you to choose what they're looking for, okay? It says, Coach Mahoney ran 6 times as fast as far as he swam, cycled 30 times as far as he swam. If he covered a total of 37 miles in the triathlon, how far did he swim? So what are we looking for? How far did he swim? So how far did he swim is our variable. So what we're going to say is something like this. X equals how far, so we can just say far he swam or swim, okay? All right, so X is how far he swam, okay? Now, how far did he run? So let's go back to the equation. Now that we have a variable, okay, so we start with writing our variable, then we go back and we put it into an equation. So here's what it said. Coach Mahoney ran 6 times as far as he swam. So 6 times what? 6 times how far he swam. So 6 times X. Okay, that's how far he ran. Does everybody follow that? So 6 times swimming. Then it says he cycled 30 times as far as he swam. So 30 times X. So what is this one? This is how far he ran. This is how far he rode his bike. Okay, so we have X is the number of miles he swam, or like whatever was swimming. 6x is the number of miles he ran, and 30x is the number of miles he rode. So now, what it says in the end, it says, if he covered 37 miles. So all 3 of these together is he covers 37 miles. So how would I solve this? Carter, can you answer that for me? So how is he going to solve for this? He's going to do what? He's going to add them together. So he's going to add his swimming with his running and his biking. Good job, Carter. So we're going to add them. So it's going to be x plus 6x plus 30x. All equals how many miles? How many miles? Okay. Overall, it said 37. Good. So does everybody follow that? So do we see our equation? Now, from last section, what would our next step be? Well, we could combine. So x plus 6x plus 30x is what? 1 plus 6 is 7. 7 plus 30 is 37. X equals 37. Now what do I do? Divide by 37. X equals 1. So he swam how many miles? 1 mile. He swam 1 mile. He ran 6 times 1, so he ran how many miles? Whitney? Good job, 6. And Sophia, how many miles did he ride his bike? 30 times X, which is 1, and the answer is 30. Good. So does everybody follow what you do? So what are our steps? First off, we have to identify our variable. First off, 1, identify our variable. Okay, 2. What do we do second? We put the conditions. Look, so we put things together. So X swam, so he ran 6 times. So we put it into the problem. We separated the different conditions. Separated different conditions. 3. What do we do next? We identified what they were equal to, see? So we put it all equal to 37 miles. We set up an equation. Set up equation, which is when you set up an equation, you find what it's all equal to. And then lastly, number 4 is you just got to solve it. You just got to solve it. All right? So we have 4 steps. We've got to identify our variable, so what we're solving for, identify different conditions. Number 3, set up an equation. Number 4, solve. All right? So write those 4 steps down. We'll get ready to do the next problem. Okay? Get ready to do the next problem. All right? We'll keep our steps up there as we read this problem. So we're going to read this second problem. Here we go. All right, everybody paying attention. This is Animal's favorite problem because it's a soccer field problem. All right, here we go. A soccer field has a perimeter. So what's a perimeter? Anybody know what a perimeter is? It's the edge of the soccer field. So here's our soccer field. Okay, so it's all the way around. A soccer field is a rectangle, right? Okay, so we have a soccer field. It says the perimeter, the perimeter is 380 yards. So the whole perimeter is 380 yards. Okay, then it says, and its length, so the length from here to here is 40 1/3 yards longer than the width. Longer. So when you hear the word longer, what do you think of? Do you think of multiplication or addition? You don't think of subtraction, you don't think of division. So when you say it's longer than, so if I said, I went to the office and it took me longer, are you going to multiply the time or are you going to add time? Ish? Add time. Good. So we're going to add distance. So we're going to talk about width, W, and then remember, what is the width? The length is what? The length is W, the width, longer, what? Plus 40 1/3. 40 1/3. So now, we have W, and we have W plus 40 1/3, okay? Now, what do we do next? So, how many widths are there in our soccer field? 2. And how many lengths do we have in our soccer field? 2. So, what will we do in order to solve this problem? So what did? We first identified our variables, right? Second, we separated our conditions. We did the conditions, right? The width, and then the width 40 plus, or width plus 40 1/3. Now, let's set up our equation. So how will I get the whole perimeter? What will I do to get the whole perimeter, Candace? So if I want to get all the perimeter together, what will I get to set it equal to 180? Good, I'm going to add them all up. So what are the 4 things? W plus W, we got our two its, plus W plus 40 1/3 plus W plus 40 1/3, all equals to 380. So we have an equation, okay, step 3, because step 1 we found our variable. Step 2, we found our condition with our variable. Step 3, we found our equation, we put our equal sign in here, okay? Now, what do we do next? We got to solve it. Well, how do we solve it? Add like terms. Add like terms. 1W, 2 W's, 3 W's, 4 W's. So we're going to put here 4W plus, now if I add 80, or 40 1/3 plus 40 1/3, I have 80 2/3 equals 380. Is that correct? Now what do I do? Well, I have to move it over. Yes, good. We got to move it over. So you subtract 80 2/3. 80 2/3. Do you guys know how to do that? 4W equals, so what do I got to do? Well, I need to borrow here, so it's going to be 379 and 3/3. So what am I left with? 1/3 and 379 minus, it's going to give me 299 and 1/3. Okay, now what do I do? Well, we're going to divide by 4 both sides, right? When I divide by 4 both sides, I'm going to get my answer, okay? All right, you won't completely solve this one. This is a difficult one to solve. You won't have to solve any this hard in your homework, okay? All right, any questions on setting it up, identifying, separating the conditions, setting up the equation, and then solving, okay? This is the hardest one. You won't have to actually solve this one by yourselves. We won't get to that point yet, all right? Okay, any questions? All right, so let's do 2 more. Let's do 2 more. I think you're getting the hang of it. All right, so we'll leave our steps up. We'll leave our steps up, all right? Here we go. All right, so here we go. A carpenter is nailing backboard molding along a wall that is 88 inches long. He has nailed it in place a piece of molding that is 32 inches and 5/8 inches long. What length of molding does he need to finish the job? So let's think through. So what are you looking for? You're looking for what? M. We're looking for some molding, right? We're looking for some molding. Okay, and now what does it say? Let's go back. So we're looking for M, right? And it says this. How long is the whole wall? How long is the whole wall that we're putting this up on? Let's pretend that this is our wall. And he has a wall, this is 88 inches long, right? The whole way. And it says in the problem that he has a piece that is 32 inches and 5/8. What is M? M is this right here, right? It's the rest of the wall. So what would we do? What's our equation? So we have M, we have our condition. So what are we going to do? M plus 32 and 5/8 equals how far? 88. So now what do we do? Well, we just have to do what? We got to solve for M. So what's our next step? Subtract both sides, 32 and 5/8, 32 and 5/8. All right, so now when we do this math over here, remember, we borrow from this 8, we borrow from that, make it a 7, and we do 8/8. So 8/8, let's see who haven't I called on today. Oh, Kyle. So what would it be? 8 minus 5 is 3. Good. So 3/8 right here. And 87 minus 32, what's it going to be? So 7 minus 2 is 5. And 8 minus 3 is 5. So how big of a piece are we still looking for of molding? 55 and 3/8 inches. Okay? All right, does everybody understand how we got that problem? Okay? So we found our variable. We set up our equation so we could see it, our condition, and then we set up our equation. All right? Any questions? All right, let's do one more. do one more. Here we go. The drama club performed the school play on Friday and Saturday night. The attendance at the Saturday performance was 1 1/4 times the attendance on Friday. If there were 95 people in attendance Saturday, what was the total attendance for the performance? So, what are we looking for? We have to look for the Friday attendance. So, what would the Friday attendance look like? Okay, what would the Friday attendance look like? So first off, Sal, what do we want to use as our variable? If we're looking for Friday's attendance, what would it be? Friday's attendance, we're going to use the letter, whatever, so you say F. All right, good, F. Okay, so F is our Friday attendance, remember? So we have our variable, Friday attendance. Now what? So we have our Friday attendance, and then we have what? What's our next thing, sorry? Okay, now what's our next thing? We need to find out, what are we looking for? The Saturday attendance, right? So the Saturday attendance is equal to what? If you go back and read it, it says, attendance on the Saturday night performance was 1 1/4 times the attendance on Friday night. So what is the Saturday? Is 1 1/4 times F, okay? So that's your Saturday night, I'll put it as Saturday, your Saturday night attendance. Now, in the problem it says this, if there were 95 people attending Saturday night, how would we solve this? So remember, this is our equation, all right, this is our variable and condition, so now we need an equation, 1 1/4 F equals 95. Okay, so now what do we do? Well, we need to make a mixed number. So 1 times 4 plus 1 is going to be 5/4 F equals 9/5. Now what do? How do I solve this? I got to do what? I got to multiply by the inverse, right? So what's the inverse? 4/5, 4/5. These cancel, right? F equals 9, 5 goes into 9, 1 and 19 times, right? So now 19 times 4 is, so we do the math over here so you can see it, 36 carry 76. So F is what? Our Friday night attendance. What did the question ask for? Let's read the question again. What was the total attendance for the whole performance? So the whole performance on Saturday night, how many people came? 95. On Friday night, how many people came? 76. So how many would the whole be? How would we get the whole? 95 plus 76, 1, carry the 1, right? And 17, 171. So the total attendance for both nights is 171. So you make sure when you're doing these problems, you have to sometimes solve it and then plug it back in. So you got to be careful because they sometimes will ask you to do specific things. So you have your homework, you can do this, do your best, and I will see you on Monday.